For Unit 2, Lesson 2 will be on the periodic table, nature's building blocks. So in this lesson, we're going to learn a little bit about the periodic table and what exactly it's showing us and how we can recognize the parts of the periodic table when discussing an introduction to chemistry. So first and foremost, what is the periodic table? This is something that may be review for you. We may have talked about it in class. You may have read about it, but it's always good to hear things multiple times. So the periodic table, this thing here on the right side, consists of all of the known atoms of the universe. So as we discover more things, as we explore more as human beings and explore the universe, the elements that are within the periodic table and the atoms for those elements may be added to this periodic table. And so we might add a new element here if some scientist discovers it, and that will indicate that there's another substance out there that we never knew about. Each box contains important information about a different atom. So it's important to recognize that we call these things elements, but each element has its own specific atom within each of these boxes. And we'll take a look at some specifics and how to recognize the differences in this presentation. And then these atoms combine to form millions of different substances. So these elements, though they are the most basic, which is why we call them the elements, when we put them together, we get all of the things that you're more familiar with in life. And we'll talk about what that means, what that looks like too. So a common misunderstanding is the understanding the difference between atoms and elements. So an element is a pure substance made up of only one type of atom. Okay, and an atom is the smallest particle of matter for a specific element. So let's take a look at this. This is sort of like the periodic table, but using models that represent atoms instead of the letters, the chemical symbols that you see down here in a traditional periodic table. So this, I think, is really cool because it shows that every element has a unique type of atom. Okay, and so we talked about how going from left to right on a periodic table in general increases the mass, and each column is a particular group of atoms that has a common relationship or a common properties. And so they're sort of like in the same group. And so I just wanted to show you guys that to see that each element has a specific atom associated with it. Zoom on back out of here. And then an example of an element that has only one type of atom could be gold, so pure gold. So if we look at this big hunk of gold here and say that it's a pure substance, that means that the only atoms that are going to make up that gold block there is going to be atoms that are gold atoms. Similarly, this iron and magnesium block over here, if we say that it's pure magnesium, then we're going to say it's only composed of atoms that are magnesium atoms. And so that means if we look at the periodic table, and let's find gold here. I got to zoom in. So gold would be 79 right here. So the chemical symbol, we'll talk about what that means in a minute, but is Au, 79. And so that particular atom, if it looked like that, we would say a pure substance such as gold would only have that particular atom making up that gold block. Okay, and much in the same way, talking about gold or magnesium, if we take a look at this pencil and the tip and say that this tip is composed of carbon, the carbon atoms might look like that. And I know you've seen this before, but this would be a more appropriate image of an atom because it contains the nucleus with the protons and neutrons, but also the electrons surrounding that nucleus. And so carbon would be here, periodic table. So the carbon atoms are there. And so think of it like atoms are the what it looks like, and then the elements are really like the name. What we would call a particular atom based on its unique characteristics. So we have these most basic atoms, and so when these atoms combine with other atoms in the periodic table, that's when we start getting into words like molecule or maybe compound. So a molecule consists of two or more types of atoms of different elements. And so it doesn't have to be different elements. But in this scenario of water, we have different elements. And so H2O, written H2O, the O is a subscript because it's below the letter H. It goes down, subscript. So that indicates that there are two H atoms. And since there's nothing written there, we say that there is one oxygen atom within an H2O molecule. Okay, and so when we look at atoms and we say, okay, there's a hydrogen atom right there. We got we have the proton there in the nucleus, and we have the negatively charged electrons surrounding. So that means we have one atom, two atom, and three atoms. So within an H2O molecule, we have three atoms. Okay, three atoms. And how many different types of elements do we have? Well, we only have two. Okay, we have H, which is hydrogen, and we have O, which is oxygen. So you can see that molecules will form a variety of numbers of atoms, whether or not they're repeats or any number of elements. But when we combine atoms, we form what's called molecules. Okay, so now taking a look at the periodic table and really wanting to understand each element within the periodic table, we sort of pulled up this, straighten out, there we go. We pulled up this block here to represent carbon. So carbon is located right here in the periodic table. So it has an atomic number of 6. Okay, so atomic number, which is the most recognizable large number in the periodic table up here in the top left, that would indicate the number of protons in the nucleus of the atom. So the number of protons. Remember, positive charge for protons. The element name is at the top. Okay, and then we have the symbol, which sometimes matches the element name, but not always. So remember in that example I just showed you with gold, gold's chemical symbol is AU. I'm not sure why that is. Maybe it's part of the fact that it comes from a linguistic background. It's not, even though we say it in English, maybe the origin of the word comes from a different background, such as Greek or Latin, and so maybe the chemical symbol is related to that previously written word. Then the other most important feature within the element box here is the atomic mass. Now, you'll notice that the atomic number is only the number of protons. And that is because the number of neutrons can change within a particular element. And so an atom for carbon may have 6 neutrons as well, but it could have more neutrons. And we'll talk about what that's called in a minute. So the reason that the atomic mass is going to have these decimals is because we'll learn that as an element and an atom of an element can have different numbers of neutrons. This mass here is going to end up being the average of those different types of atoms. Okay, so let's just jump in and take 2 slides. This number here would be an average of the isotopes that a specific element can be talking about there. Slide. So what we're talking about here is isotopes. So an isotope is an atom with the same element with different numbers of neutrons. So if we take a look at carbon here, which has, in this model, has 6 protons and 6 neutrons. The mass number, or the atomic number there, could be 12. Mass number is just going to be the addition, protons and neutrons, to be 12. But an isotope is when a particular item can have, a particular atom, not item, can have more than one neutron. Sorry, not more than one neutron, but different numbers of neutrons. So carbon with a mass of 13 could have an additional neutron. Carbon with even another neutron could have 8, which means its mass number would go to 14 if we say 8 plus 6 is going to give us 14. And so going back to, okay, and so we have the same number of protons, 666 there, but the neutrons can change. And so we call an atom that has a different number of neutrons than the matching number of protons, we call these isotopes. So this would be a carbon-13 isotope, carbon-14 isotope. And so what does that mean? That just means it's inevitably going to behave differently, react differently. We can just imagine as you add more stuff to something, it's gonna change the way it behaves. It's gonna react differently when you put it with different substances in life. So we won't go into detail about that. That's a little bit more advanced, but just understanding what isotopes are, and especially how it in fact impacts the atomic mass. This slide is talking a little bit about what I just mentioned. So again, atomic mass versus a more familiar term for when we average the isotopes is going to be atomic weight. So atomic mass is simply the protons and the neutrons added together. So it's a whole number. But when we talk about atomic weight, that's when we get this number with decimals based on the varieties of isotopes. So boron could have 5 protons, 5 neutrons, but an isotope could have an additional neutron here, giving it 6. And so when we start looking at all the different isotopes of boron and finding the average mass, that's what we would call the atomic weight. So you might see lots of different terms for the mass or the weight, but just understand that there's generally 2 different varieties: adding up the protons and neutrons, or finding the average of all of the different isotopes. And so you'll get one of those 2 different words indicating what that means. Okay, we're going to stop there, and that was lesson 2, just understanding the building blocks of nature and the periodic table and how it affects things like building molecules and having atoms come together to form different molecules of different elements.